Hello and welcome back to the latest video of the Python series by the Knowledge Academy. Today, we will go through our first practical code implementation, so sit tight and happy coding. In the first code, the print function serves as a feature in Python, allowing it to display text or data on the screen when utilized. It accepts one or more arguments, which can be values or expression to be exhibited. The string hello coders is enclosed with single quotation marks. In Python, a string is considered a sequence of characters, and in this specific case, the string contains the phrase hello coders. It's worth noting that Python allows the use of either single or double quotation marks to represent strings, both of which are considered entirely valid. When this code is executed, it will display hello coders on the screen. This output will be visible in the console or terminal when the code is run. The code is broken down step by step. The script begins with the assignment of x equal to 5. At this point, a variable called x is created, and the values 5 is assigned to it. In Python, variable creation is a straightforward process, involving selecting a name, in this case x, and utilizing the assignment operator equal to provide it with a value. Following that, there is the line y, John. In similar fashion, another variable named y is established, and it is assigned the string value John. Python is flexible in that it permits the assignment of various data types to variables, including integers, strings, floats, and more. Lastly, the code utilizes the printx function. The purpose of the printx function is here to display the value of the variable x on the screen. In this code, you can observe how a variable's data type undergoes changes during program execution in Python. The process begins with the initialization of a variable denoted as x. With the initial value of 4, at this stage x assumes the data type int, signifying an integer data type. Subsequently, the value of x is reassigned to Sally, which is a string. Python's flexibility allows the variable to adapt to different data types as needed. X is now categorized as string. Finally, the script employs the print function to display the current value of x. Now, in this scenario, two variables, namely x and y, have been defined for the variable x. An initial value of 5 has been assigned. When the type function is employed to determine its data type, it returns class int, clearly indicating that x is of the integer data type. In this case, y, the string John, has been assigned as its value. Upon using the type function to ascertain its data type, the result class string providing confirmation that y is indeed a string. To summarize, it can be included that x is an integer while y is a string. Python allows the use of either single or double quotation marks to represent both, of which are considered entirely valid. In Python, it's essential to note that variable names are case sensitive, distinguishing between lowercase and uppercase characters. As a result, variables like a and a are perceived as distinct entities with the language. They do not overlap or overwrite each other because their names differ due to casing. In this scenario, there exist two separate variables, a and a. Their distinct name ensures that they are treated as separate entities within the program. The variable a has been assigned the value 4, signifying an integer data type, while the variable a has been assigned the string Sally. Now, in Python, specific rules and conventions must be adhered to when creating variable names to ensure their legality. The provided variable names all conform to these standard rules. The first one, the variable myvar, is assigned the value John. This naming convention employs lowercase letters and underscores, which is a widely recognized practice in Python for variable naming. Similarly, myvar is assigned the value John, maintaining the convention of using lowercase letters and underscore for variable names. Starting a variable name with an underscore as seen in myvar is permissible. However, it's important to note that variables with leading underscores have often special meanings or are considered private within a module. The variable myvar is assigned the value John, employing a combination of lowercase and uppercase letters. This is allowed in Python, but it's crucial to remember that variable names are case sensitive. So myvar and myvar would be treated as distinct variables. Now, Using all uppercase letters for a variable name, as in myvar John, is also permissible. However, it's considered a convention in Python to use uppercase variable names for constant or global constants. Furthermore, variable names can incorporate numbers as long as they don't start with a number. For instance, myvar2 John adheres to this rule and is a valid variable name. In this second code, the example of variable names provided in the previous statement are in fact not legal in Python, as they do not adhere to Python's naming rules. To_myvar is an invalid variable name because variable names cannot commence with a numeric digit. They must initiate with a letter A to Z or caps A to Z or an underscore. Similarly, my-var is also an illegal variable name. Python prohibits the inclusion of hyphens or special characters other than underscores in a variable names. Only letters, numbers, and underscores are permissible. Additionally, my_var is not a valid variable name as it contains spaces. Variable names in Python are prohibited from having spaces. They must consist of continuous characters without spaces. Now, let's talk about this code. Python permits the assignment of values to multiple variables in a single line. A practice commonly referred to as multiple assignment or unpacking in the provided code example. Values like orange, banana, and cherry are assigned to variables x, y, and z respectively, all within a single line of code. This efficient technique simplifies the assignment of values to multiple variables simultaneously. Now, Python allows for the assignment of same values to multiple variables in a single line, ensuring that all these variables hold exact identical values. In the provided code example, this feature is utilized to its advantage. The string orange is assigned not to just one variable but to 3 variables simultaneously, x, y, and z, all within a single line of code. It's worth emphasizing that when the values of these variables are subsequently printed, they will all indeed contain the same value, which in this instance is orange. This approach serves as a practical and efficient means of initializing multiple variables with identical values, streamlining the coding process. Unpacking a collection. Within the fruits list, there exist 3 elements: apple, banana, and cherry. Through the utilization of multiple assignments, these values have been allocated to the variables x, y, and z respectively. Because of this operation, the variable x now holds the value apple, y takes on banana, and z stores cherry. Upon proceeding to print the values of these variables, it becomes evident that each variable contains the corresponding value from the fruit list. This operation effectively unpacks the collection into distinct variables, simplifying the process of working with individual elements. In this code example, we initiated the process by assigning the integer value 5 to a variable denoted as x, and subsequently the type function to determine the data type of the variable. The sequence of events unfolds as follows. Initially, the code sets x equal to 5. The integer value 5 is allocated to variable x, effectively assigning the value 5 to x. Following this assignment, the code utilizes the print type x statement. Within this line of code, the type function is employed to scrutinize the data type of x. Upon executing this specific line of code, the resulting output is as follows. The type function call yields the result class int, which serves as a clear indicator that the variable x is of the integer data type. In essence, x represents an integer variable housing the value 5. Now, variables of numeric types are created when you assign a value to them. Now, here's a detailed breakdown of the process. We commence with x equal to 1. We allocate the integer value to the variable x. This action results in the creation of integer variable denoted as x. Next up is y equals to 2.8. Here, we assign the floating value 2.8 to the variable y. This operation leads to the establishment of a float variable known as y. Lastly, we proceed with z is equal to 1j. In this instance, we assign the complex number 1j to the variable z. Therefore, a complex variable designated as z is brought into existence. When we proceed to print the data types of these variables, we find that the type function confirms the data type of variable x, y, and z, which are integer, floating point, and complex numbers respectively. Now let's talk about each of these data types one by one. Let's talk about integers. Here's a breakdown of the process. We initiated with x is equal to 1. At this stage, we assigned the integer value 1 to the variable x, effectively creating an integer variable designated as x. Following that, we moved on to y is equal to 3565. This is a large integer value to the variable y. This operation likewise results in the creation of an integer variable specifically denoted as y. Lastly, we address z is equal to -3 to 55522. In this instance, we assign the negative integer value to the variable z. Once again, this action leads to the establishment of integer variable known as z. When we proceeded to print the data type of these variables, the type function proficiently recognized that all three variables x, y, and z are indeed of the int type, signifying integers within Python. Now, let's talk about floats. We began with x is equal to 1.10. At this point, we assigned the floating value point 1.10 to the variable x, thereby creating a floating point variable denoted as x. Continuing, we addressed y is equal to 1.0. Here we assigned the floating value of 1.0 to the variable y. This action also leads to the creation of floating point variable specifically referred to as y. Lastly, we proceeded with z is equal to -35.59. In this instance, we assigned the negative floating point value -35.59 to the variable z. Once again, this operation results in the establishment of a floating point variable known as z. When we proceeded to print the data type of these variables, the type function adaptedly discerned that all three variables x, y, z belong to the float data type, signifying floating point numbers in Python context. Now, let's talk about float into more detail. So we have x is equal to 35e to the power 3. In this line of code, we have assigned the value 35e to the power 3 to the variable x. This value is expressed in scientific notation representing 35 into 10 to the power 3 or 35,000. Consequently, it creates a floating point variable referred to as x. Moving on to y 12e to the power 4, this value is also in scientific notation. It results in the creation of floating point variable denoted as y. Lastly, we have dealt with z is equal to -87.7 into e to the power 100. As a result, it will also create a floating point variable known as z. Now let's talk about the complex numbers. We commenced with x is equal to 3 plus 5j. At this point, we assigned the value of 3 plus 5j to the variable x. Moving forward, we proceeded with y is equal to 5j. Here, we assigned the value of 5j to the variable y. Much like the previous case, it resulted in the creation of a complex variable denoted as y. Lastly, we address z is equal to -5j. In this instance, we assigned the value of -5j to the variable z. Like the previous cases, it generated a complex variable referred to as z. Now, when we subsequently proceeded to examine the data types of these variables, the type function proficiently identified that all the three variables x, y, and z belong to the complex data type. Now, how to convert the data types? First, we executed a float of x. This involved the converting the integer x, which had the value 1, into a floating point number. As a result, the variable a now holds the value 1.0. Next, we proceeded with b int of y. In this step, we converted the float y with the value 2.8 into an integer. The conversion truncates the decimal part, so b becomes 2. Lastly, we address c complex of x. Here we converted the integer x having the value 1 into a complex number. This complex number has a real part of 1 and an imaginary part of 0. Consequently, the variable c becomes 1 plus oj. Upon printing the values of a, b, and c alongside their respective data types, our code effectively demonstrates these type conversions, and the type function accurately gives us the data types of a, b, and c. Specifically, a is identified as float, b as an int, and c as a complex number. Now let's talk about Python casting. We initiated with x is equal to int of 1. In this case, we explicitly converted the integer 1 into an integer, which may seem redundant. 1 is already an integer, x retains its value of 1. Next, we addressed y in 2.8. Here we converted the float 2.8 into an integer. This conversion effectively truncates the decimal part, resulting y taking on the value 2. Lastly, we proceeded with z is equal to int of 3. In this instance, the string 3 converted into an integer using the int function. The int function adaptedly achieved the conversion, transforming the string into integer 3, therefore z assumed the value of 3. Upon printing the values of x, y and z, the output reflected the outcomes of these conversion. X remained 1 as it's already an integer, y became 2, and after converting z it became 3, following the successful conversion of the string. This underscores the flexibility of Python's int function in handling various input types. Now, in this code, we began with x is equal to float of 1. In this scenario, we changed the integer 1 into a float. The outcome becomes 1.0, representing a floating point number. Moving on to y, float of 2.8, we attempted to convert the float 2.8 into a float. Even though it was already in that form, y retains its original value of 2.8. Next, we addressed z is equal to float of 3. In this case, we converted the string 3 into a float using float function. This conversion was successful, leading to z adopting the value 3.0. Similarly, we carried out w float of 4.2. Once again, we explicitly converted a string 4.2 into a float. Mirroring the previous situation, the float function transformed the string into a float, resulting w being assigned the value of 4.2. Upon printing these variables, the outputs reflect the outcomes of these explicit float conversions. Specifically, x becomes 1.0, y remains as 2.8, z becomes 3.0, and w takes on the value 4.2. Now, in this code, we commenced with x is equal to string s1. In this scenario, we explicitly converted the string s1 into another string. As it was already a string, x retains its original value of s1. Next, we addressed y, string of 2. Here we converted the integer 2 into a string using string function. The outcome is string 2. Lastly, we proceeded with z is equal to string of 3.0. This case, we explicitly converted the floating point number 3.0 into a string. The conversion results in the string 3.0. Upon printing these variables, the output reflects the consequences of these explicit string conversion. Specifically, x remains s1, y becomes 2, and z transforms into 3.0. Now, in Python, strings can be surrounded by either single quotation marks or double quotation marks. Both are equivalent for defining string literals. Both print hello inside double quotation mark and print hello inside single quotation mark will produce the same output. You can choose single or double quotation marks based on your preference or to accommodate specific formatting requirements in your code. Now, in this code, we are assigning the string hello to a variable a and then printing the value of a. Here's what's happening. A is equal to hello. We are assigning the string hello to the variable a. This means that a now holds the value hello. Print of a. We are using the print function to display the value of the variable a. Now, we initiated with a is equal to welcome to the Knowledge Academy. Thank you for joining us today, and this is the finest learning platform. In this step, we assigned a multi-line string to the variable a. The usage of triple double quotation marks facilitates the creation of a string that spans multiple lines, allowing for a more organized and readable format. Next, we proceeded with print a. Here we employed the print function to present the content stored within the variable a. This function serves to display the multi-line string, making it visible on the screen for users to read and comprehend. Now, we initiated with a is equal to hello world. At this point, we defined a string labeled a containing the text hello world. Following that, we proceeded with print a of 1. In this step, we utilized the square brackets along with the index 1 to access the character situated at position 1 within the string a. In Python, it's important to note that the string indexing begins at 0, meaning that the character at position 1 corresponds to the second character in the string. By executing this code, we successfully showcase the principle of string indexing, which plays a fundamental role in extracting specific characters or substrings from the string in Python. Now, in this code, the for loop iterates through each character in the string banana. In each iteration, the variable x takes on the value of the current character in the string. The print x statement inside the loop prints each character one by one. To get the length of a string, use the len function. To check a certain phrase or a character is present in a string or not, we can use the keyword in. So here's a concise explanation of what's taking place. We commenced with b is equal to hello world. In this step, we created a string denoted as b, containing the text hello world. Following that, we proceeded with print b to ratio 5. Here we utilized square brackets and a colon to define a slice of the string b. The slice 2:5 encompasses characters starting from position 2 and extends up to but does not include position 5 within the string. We began with b is equal to hello world. In this step, we established a string referred to as b, containing the text hello world. Next, we proceeded with print b is to 5, where we utilized square brackets and a colon to specify a slice of string b. By omitting the start index, the slice automatically commences from the very beginning of the string. At position 0, the slice encompasses characters up to but does not include position 5 within the string. To slice the string to the end by leaving out the end index, the range will go to the end, get the characters from position 2 and all the way to the end. Now, talking about negative indexing, use negative indexes to start the slice from the end of the string. Get the characters from O in world position -5 to but not included D in world position -2. The upper function method returns the string in uppercase. The lower method returns the string in lowercase. To remove white space, the strip method removes any white space from the beginning or the end. Split string. The split method returns a list where the text between the specified separator becomes the list items. To merge a variable with b into variable a, we use this function. So here it is. If you liked this video, hit the like button, subscribe to our channel and share it with your friends.